All right, welcome class. Today's discussion is on what we call chemical nomenclature, and chemical nomenclature is nothing more than learning how to name chemical compounds. And it's actually a relatively simple and painless process for the types of chemicals that we're going to deal with. And we're starting with inorganic chemical compounds. Later in the year, probably one of the last things we'll do this year, we'll be dealing with organic chemistry, and a lot of that will be dealing with either identifying types of compounds or naming organic compounds. And that is a whole separate procedure. So we're going to deal with organic compounds first, and the naming procedure for inorganic compounds is actually pretty easy. A lot of it simply has to do with this. If you sometimes are going to put a prefix, and we're learning the Greek prefixes already, or we should be, and then you're going to put a suffix on the end, and that will pretty much be able to help you to identify something. There's a few other little tricks of the trade that we'll learn in there, but overall that's pretty much it. And so basic chemical compounds are pretty simple to name. So we're going to get into the rules here. What are some of the basic rules behind that? And you notice these are basic rules for naming binary covalent compounds. All that means, a big fancy word binary, is it simply means compounds with two elements in them. Is what it is. And you'll also notice that we're dealing with covalent compounds, not ionic. There's some separate rules for ionic, and actually ionic, to be honest with you, binary ionic compounds are even easier than covalent compounds. So we're going to learn the one that is, if you want to say, quote unquote, complicated, even though it's not really complicated at all. So rule number one simply says this: use Greek prefixes to identify how many of each element you have. That's kind of our starting point. And you guys should be kind of memorizing your Greek prefixes already, or at least have them on note cards, and they're real easy. And so it's a situation where if you have, let's say, two hydrogens, then you would put the prefix di in front of it to identify that you have two of them. If you had four, let's say, nitrogens, then you would put the prefix tetra. So that tetra tells you that you have four nitrogens, so tetra nitrogen in front of that. If you had 8 of something, you'd have the prefix octa. So that's kind of the first thing you do, is how many of each element you have, and before you actually name the element, you want to put the Greek prefix to tell you how many you have. And so that's pretty simple and pretty straightforward. Rule number 2 is the first element in a compound receives its full chemical name. So after you've put the prefix, so if there's 3 of them and you put tri, then the first element in the compound receives its full chemical name. And that you can just take right off the periodic table. So if it was hydrogen and there were 3 hydrogens, you would say tri, and then the element gets its full name, so it'd be trihydrogen. If it was nitrogen, it'd be trinitrogen. If it was chlorine, it would be trichlorine, so on and so forth. You guys get the idea. So that's basically the first element always gets its full name, and you're just going to take that right off the periodic table. You're not going to change anything at all. So the prefix comes first, then the first element gets its full name. The second element is the one that you have to change a little bit, and the second element in a compound is going to drop its ending, and you're going to add the suffix ide, or ide. And some of these, it'll be real easy for, like fluorine and chlorine and bromine and iodine, all of those that end in ine. Then it's real easy because all you drop is the ine and you add ide. So it's real easy on some of those to do that. On some of the other ones, like oxygen and sulfur that don't end in ine, it's a little different, but again, you're going to end in ide, so you kind of cut it off where it would make sense. So for like oxygen, you're going to drop the ending and it becomes oxide instead of oxygen. It becomes oxide. For sulfur, you're going to drop the UR and it becomes sulfide is what it ends up being. And a lot of it just makes, it's kind of common sense as you go through it. So again, for the second element, you're still going to do the Greek prefix, whatever the Greek prefix might be, and then you're going to add the IDE on the end. of that. There's going to be a suffix, so that it'll have a prefix and a suffix on that second element. So that, and once you've done that, then you're done naming the compound. That's all there is to it. So let's kind of look at a few elements and see how does this work, and then you should be able to do it on your own. The first element here is we often call water. That's actually not its correct name. And part of the reason for all of this naming process is to better identify different compounds. And I probably should have mentioned this earlier, but some of the things as through the years you had people that discover sometimes the same compound but in different areas of the world, and they would call it different things, and so there would be some confusion. And so to limit that confusion, we've come up with a standard way of naming. This is how we always name elements and compounds as we come down to it. So obviously this is commonly known as water. You have H2O. How do you go about naming it? Well, if you remember, the first rule says we want to use the Greek prefix for whatever that might be. In this case, you have hydrogen has two atoms or two of the element there, and so we're going to use the Greek prefix di. That's what's going to come first. And then the first element, which is hydrogen, gets its full name, so it would be dihydrogen. And then the last element, you only have one of them, so you can actually do one of two things here. Normally, actually, you will not use a Greek prefix for if you only have one of them. There are some exceptions to that rule. For example, if you had carbon and oxygen together, there's several different ways you can put it together. You can have carbon with a single oxygen. We call that carbon monoxide. So that's where the mono comes in. And then we have carbon dioxide, which you're familiar with, CO2. And the reason you want to use the mono there is to kind of distinguish it from the dioxide there, because they're very similar in their compounds. But a lot of things you're not going to use mono in. Typically you don't. This is dihydrogen oxide. If you want to say dihydrogen monoxide, it's the same thing. Either way works. And I would accept both. And so here's how we would name this. Di, because of the two. Hydrogen, it gets its full name. And then the second element there, we drop the ending and add the IDE. And so you have dihydrogen oxide, or if you wanted to say dihydrogen monoxide, that would be acceptable as well. Here's another element, or compound. And you have phosphorus and chlorine here. You notice phosphorus, we only have one of them. And so you can either use the Greek prefix mono for one, or you can just name the element. It's not necessary a lot of times to use the mono prefix. And so in this case, we would say phosphorus, because the first element gets its full name. And then the second element, first you want to identify how many there are. There's three, so that's going to be the Greek prefix tri. And because it's chlorine, it's going to drop the ending INE. And instead we're going to replace it with IDE, and so we end up with phosphorus trichloride is how this would be named. And so that's how you go about naming that particular one. And let's have one where we have multiples of each element there. So for example, here you have chlorine and oxygen bonded together, and you have more than one chlorine and you have more than one oxygen in this situation. And so we take a look, and the chlorines, you have two of them, so we're going to use the Greek prefix di. And then because it's the first element, chlorine is going to get its full name, so it would be dichlorine. And then we need to identify how many of the second element we have. So we have 7, so that would be the Greek prefix hepta. And because this is oxygen, we're probably going to drop that A, so it just becomes hept. So you have dichlorine, hept, and then it's oxygen. We're going to drop the ending, add IDE, and so it becomes oxide. So the full name altogether is dichlorine hept oxide is how you would write that. And I've had students ask me in the past as well, do you have to include the dash in between the prefix and the name? Not necessarily. I've actually seen it written both ways. I've seen it written with the dash. I've seen it written without the dash. And so I'm not going to get real cranky in terms of how you personally choose to do it. I would accept either. So that's basically how we go about the naming process with covalent compounds. Remember, this is covalent compounds, where you have a nonmetal with a nonmetal. Ionic is going to be a little bit different, and actually it's going to be even easier. We don't even have to use, with ionic, we don't have to use the Greek prefix system. That kind of gets thrown out the window. All you need to name is the metal and nonmetal with the ionic, but we'll deal with that at a later date. So this is all there is to it, and we'll do some more practice in class.